Have you ever just stopped and asked yourself, what is actually real? It sounds like such a basic question, right? But our whole understanding of reality is built on centuries of these epic intellectual clashes. So today, we're going to dive into some of the great debates that have shaped everything we think we know, from the space around us to time itself. And let's just start with a real mind-bender. Does the future already exist? I mean, is it out there waiting for us? Your answer to that question actually depends on some of the biggest arguments in science and philosophy, arguments we're going to unpack right now.
Okay, so our first great debate is about the very fabric of the universe. Is all the space around us an actual thing? Or is it just, well, nothing?
So on one side, you've got Isaac Newton. He thought of space as this giant, fixed, unmoving stage. It's just there, whether there's anything in it or not. But then, thinkers like Ernst Mach and, of course, Albert Einstein came along and said, hold on a second. They argue that space isn't a stage at all. It's just the relationship between objects. So for Einstein, if you could magically remove all the stars and planets, space itself would just vanish. The real question is space an empty box, or is it nothing without the stuff inside it?
You know, this whole debate taps right into how our brains are wired. We didn't evolve to think about vast, empty voids. We evolved to measure things relatively. Like, is that predator getting closer? Is that berry within reach? Our survival literally depended on reference points. So it's kind of no wonder the idea of relative space just feels a little more natural to us. Okay, so if something as fundamental as space is up for debate, how do we even begin to decide which ideas are scientific in the first place? And that brings us to our next huge debate. Where do we draw the line between actual science and, well, pseudoscience? The philosopher Karl Popper came up with this really powerful idea he called falsifiability. And what he said was, a truly scientific theory isn't one that can be proven true, but one that could, at least in theory, be proven false. Think about it. The statement, all swans are white, is scientific. Why? Because all you need to do is find one single black swan and the whole theory comes crashing down. It has to make a risky bet. So let's apply this idea to ufology. A lot of the evidence relies on things like blurry photos or someone's personal story, stuff you just can't test or repeat in a lab. You can't run an experiment to prove that a fuzzy light in the sky wasn't an alien. Instead of making risky predictions about the future, it often creates explanations for things that have already happened. So by Popper's standard, because you can't prove it wrong, it lands in the pseudoscience category.
But then another philosopher, Imre Lakatos, came along and added a really important layer to this. He said, just being testable isn't quite enough. A healthy science has to be progressive. It has to make new, surprising predictions that actually come true. It has to keep getting better over time.
Let's take iridology. That's the claim you can diagnose diseases just from the patterns in someone's eye. The problem here is that the interpretations are totally subjective. You could have two iridologists look at the exact same eye and come up with completely different diagnoses. The field never makes new, verifiable discoveries. It doesn't improve, it's just stuck. And for Lakatos, that kind of stagnation is the real red flag for a pseudoscience.
And the data on this is just wow. This 51% comes from a study where iridologists were asked to find patients with gallstones. Not only did they miss most of the people who actually had them, but they incorrectly diagnosed 51% of perfectly healthy people as being sick. That's not just wrong, that's worse than just flipping a coin. It's a perfect example of a field that completely fails to make accurate predictions.
So this leads us to our third big debate. If we can separate science from pseudoscience, how does real science actually move forward? Is it a nice, slow, steady march towards the truth, or is it a lot more chaotic?
See, Popper imagined progress as this very clean, logical thing. You test a theory, you find a flaw, you throw it out, and you find a better one. Simple. But the historian Thomas Kuhn looked at the actual history of science and saw something totally different. He saw these long, stable periods where everyone works inside a shared worldview, what he called a paradigm. But eventually, weird results that don't fit, anomalies, start to pile up until the whole system breaks and a scientific revolution completely changes the game.
The classic example of this is the revolution that overthrew Aristotle's physics. For nearly 2,000 years, the paradigm was simple. Earth is the center of everything, and heavier things fall faster. But then the telescope was invented, and suddenly we saw things that just didn't fit, like moons orbiting Jupiter, not Earth. These anomalies piled up. Galileo made his groundbreaking discoveries, and then Newton came in with a whole new paradigm. universal gravity, that just completely replaced the old way of seeing the world. That's not progress. That's a revolution.
And that brings us to our final and maybe the most mind-bending debate of them all. We started by asking if the future exists, but to even have a chance at answering that, we have to ask an even deeper question. What even is time?
So on one hand, you have presentism. This is the idea that feels right to most of us. Only the present moment, right now, is real. The past is just a memory, and the future hasn't happened yet. But then there's this other, wilder idea called eternalism. This view says the past, present, and future are all equally real, all existing at once in what's called a block universe. From this perspective, the dinosaurs, your own birth, and the end of the universe are all just as real as this exact moment you're in right now.
And here's where it gets really weird. Our best theory of physics, Einstein's special relativity, actually points toward eternalism. See, relativity showed that there's no such thing as a universal now. If you and I are moving past each other at high speed, what I experience as now could be in your past or your future. And if everyone's now is different, the only way for reality to make sense is if all moments, past, present, and future, are all equally real.
But, and there's always a but in physics, right? This debate is far from over, because quantum mechanics throws a huge wrench in the works. Some readings of it suggest the future is genuinely up for grabs until we make a measurement, which sounds a lot like presentism. But then there are these bizarre quantum experiments that suggest a choice we make now can affect something that already happened in the past. The fact that our best science can be used to argue both sides just proves these fundamental questions are still very, very much alive.
So where does all of this leave us? Our concept of space is relative. The truth of our science can be completely overthrown. Even the now that you're experiencing at this very second isn't universal. It all leads to this one final, massive question. In a universe where so much of what we think is real is up for debate, is anything absolute at all?